find out with the single multiple voltage sources. So by using the concept of the source shift, here we need to find out the equivalent circuit between the terminals A and B. So what we can do here is, so here between the terminals A and B, we need to perform the current shift we need to do, or else we need to perform the E shift we need to do. So the better idea is, let us perform the current shift. We can do it here, so that we can shift the current source between the 45 amperes is there. Here we can shift like this, and here we can shift like this, and we can convert this into perform the voltage source transformation, and let us evaluate that one. So now let us perform the I shift here. So let us consider the shifting of the current source. So perform the I shift. Let us perform here. So what we can do is, we can shift the 45 ampere current source. Let us shift it, and we'll convert the circuit into the simplest form. Let us do that one. We'll shift that one. Here what we'll do is, so this 45 amperes is there, so I can shift like this. So this is the 2 ohms current source, and here the resistance is there. So we can shift. So whatever the shift is there, I'm going to indicate with the red color. So the rest of the part of the circuit will write like that only. We'll redraw the circuit diagram once we apply the concept. So here the voltage source, the value for the voltage source. So this one we are going to perform the shifting. Let us shift the current source here, and let us shift the current source here. While shifting here, we need to maintain the same polarity. The direction has to be maintained same. So 45 amperes. Here also we are going to multiply the 45 amperes, and the value for the resistance is, it's 8 ohm. This is 10 ohm, and this is 6 ohm, and 3 ohm, and this is 2 ohm, and the 5 ohm resistance. And the value for the current source, it is not given, so it is equal to we are going to assume it is equal to something called 20 volts. We are going to assume, so 20 volts is the voltage source. So this is obtained by after performing the I shift here. Now what we can do is, we can perform the source transformation. Let us convert this network into this one into the voltage source, this into the voltage source, so that all the resistance will come in series, will come here. So I'm going to rewrite the circuit diagram. The circuit diagram can be rewritten. The circuit diagram can be rewritten like this. So it is equal to so this is the terminal A, and performing the shift here. So we can modify the circuit diagram without changing any rules here. So 2 ohms in parallel with the 45 amps is there. So this will be appear as the 2 with the tail, and positive will be the idea. So the value for the voltage will become 90 volts. That is V is equal to I into R. So in series with the 8 ohm resistor. Similarly at the below, so 5 ohm resistor in series with the voltage source, in series with the 10 ohm resistor. So this is 10 ohm, and the value for this one is positive and negative. So it is 45 5s are it's 225 will get 225 volts, and this is the 5 ohm, and this is 10 ohm. So this will come in parallel with the voltage source. It's a 20 volts power supply, and in series with the, so this is the resistance are there which are connected between the terminals B. So it is 3 ohm, and this is equal to the 6 ohm will get. So this is 225 volts will get. Now we can see the 2 ohms is in series with the 8 ohms, and 5 ohms is in series with the 10. So it will become the 15 ohms will get here, and this is the rest of the circuit will get. So let us rewrite modify the circuit diagram by simplifying the value of the resistance. So it will become, so 10 ohms will get in series with the voltage source. So the value for the voltage source is it's a 90 volts. So the polarity will be taken as per the direction of the current here. So similarly here, so 15 volts in series with this one. So 5 ohms in series with the power supply of 225 volts. So between this one, the voltage source is there. So voltage source, what we can do is, so I'm going to recall the names the terminals as like this. So this is, let us say it is equal to something called C. We can rename it as something called a C here, and let us rename this as a D. We can rename here. So we can shift the voltage source in the two ways we can shift here. One is shift the 20 volts towards the node C here, or else towards the node D. Let us shift towards the node C here. So I'm going to shift like this, and I'm going to be shifted like this here. The voltage sources can be shifted like this. So the shifted voltage source, I'm going to indicate like this. So this is the voltage source. When I'm going to shift, this will become the positive polarity, so 20 volts. In the meantime, we need to shift towards this one. So when I shift it, the path between the C and D will be short circuited here. This one will be short circuited. Now the 20 volts polarity will be shifted here. When I shifted, this will become positive minus, and this is 3 ohm in parallel with the 6 ohm resistor. So we'll get, so this is the node B and this is node A, and this is a 6 ohm resistor, 3 ohm resistor, and this is the 20 volts power supply we'll get. So this is by performing the E shift we'll get here. Now we can see the 20 ohm and 90 ohm with the opposite polarity. So the difference of this one will become equal to the 70 volts we'll get. And even this one, let us bifurcate here. And let us convert this into the current source. Let us do convert so that we can reduce the network. So that let us do it here. So this circuit we can modify as a, so we can modify here. So this is a node A. This is 10 ohms will be like this only. So in parallel, in series with the voltage source, the voltage will become, so 90 minus 20 will be the 70 volts we'll get. This is in series with the, so 5 ohm in series with the 225 volts. So 225 volts we'll get, and this is the 5 ohm resistor we got here. So now afterwards, this part of the circuit diagram, let us perform the source transformation for this one. So this will become the current source in parallel with the resistance 3 ohms will get, in parallel with the resistance 6 ohm will get. So let us do modify. This is the current source, I is equal to V by R. So this will become equal to the 20 by 3, and this is 3 ohm, and this is a 6 ohm resistance will get. So this is a terminal B will get. Now we can perform the equivalent resistance between these two nodes. Let us do find out here. So the equivalent resistance will become equal to the, so it's a 3 inverse. So it will become 1 by 3 inverse. So the equivalent resistance value will become equal to the 1 ohms will get here. So 1 ohms will be the equivalent resistance in parallel with the current source. So and this one, let us do transfer this into the voltage source, this part of the network. So here the 10 ohm resistance is there. What we can do is, in order to simplify this one, we convert this voltage and the voltage source into the current source so that the other things will come in parallel. So we'll do simplify here. So let us do the simplification part here now. So this one, this part of the networks, we are going to convert into the current source so that the resistors will come in parallel and the current source also will come in parallel. So we can simplify the network into the simplest one. So performing the voltage source to current source, the circuit will become like this. So here the value for this one, the current will be, so this is the 10 ohm, and I is equal to V by R. So it is a 7 amps will get, and this is with the opposite polarity. So 225 divided by 5. So sorry, this is 15 ohm resistance, not 5 ohm resistance. 10 plus 5 will become equal to 15 ohm resistance, not 5 ohm resistance. Let us make the correction here. 15 ohm resistance. So 225 divided by 15 will be the current, and this is 50 ohms. So it is the value for the current will be equal to the, so it is 15 amps will get here, both with the opposite polarity. And for this part of the circuit diagram, so 6 and 3 will become equal to 1 ohms here. So we have the current source. This is the current source in parallel with the resistance we have. So this is the between the terminals A and B. So this is 20 by 3 in parallel with the 1 ohm resistance. So since these two are 6 and 3 are connected in series, sorry, it is connected in parallel, the equivalent will be the 1 ohms will get, that is 1 by 3 plus 1 by 6. So it will be equal to the 1 ohms will get here. Okay. sorry, this will become equal to the 2 ohms you'll get. So 2 ohms you'll get. And these two are connected with the opposite polarity. So what we can do is we can take the difference of this one, and 15 minus 7 will be 8 ohms you'll get here. So this part of the circuit will become, this will become equal to the, so this will be the current source in equivalent parallel with the resistance we'll get. In equivalent parallel with the resistance we'll get, the value for the current will be, it is 8 amperes, and the value for the resistance will be, so 2 ohms will get here. So that is so this will become, the resistance will become equal to the 6 ohms we'll get. So in convert this current source in parallel with the resistance into the voltage source in series with the resistance, we can do convert. So this will become equal to the minus plus. So this is the 2 ohms, and the value for this one is 40 by 3 volts we'll get. Now let us perform the source shift again here. Let us convert the current into the voltage source so that the circuit will become equal to, so it will become, we'll get the voltage source in series with the resistance, in series with the resistance, in series with the voltage source we'll get. So this is the node A and B. The resistance will be 6 ohm resistance, and this will be the 2 ohm. The value for the current voltage will be, so this is plus and this is minus. So 8 6 of 48 volts will get. So 6 plus 2, and this will be the 40 by 3 minus this one. So the value for the voltage source 40 by 3 will be the, so that is 40 divided by 3 will be the, this will be the 13.34 volts will get. And these are connected with the opposite polarity, so we can take the difference of this one. So 48 minus 13.34 we can take. So this will be the 34 plus 0.667 will get. So between the terminals, so the voltage will be, so plus minus, so it will be the 34.67 volts will get in series with the resistance. The value for the resistance will be 8 ohms will get. So this is between the terminals A and B, the equivalent circuit will get. So like this, we can perform the source shift, where we can shift the current source into the required one, and we can evaluate the circuit by applying the source shift like E shift